Yeah, hi. I'm happy to be here. I'm using as a user, but also providing EasyBuild configs here at JAC, and one of my things or our topics, OpenGL in EasyBuild, is there since quite some years here in our software stack. So just a few words on myself. So I'm from doing interactive HPC. Here visualization is one of the key topics. So also cloud HPC coupling, Jupyter Lab ecosystem, adding that to the software stack. Of course, a lot of EasyBuild. You can see I started supercomputing in 1990 with my Amiga 500. And now the systems are a little bit bigger. So what is the motivation for this talk? Motivation for this talk is primarily the visualization software, ParaView, Visit, and so on. You know, everything which is can take a benefit from OpenGL, and especially from hardware accelerated OpenGL. And there are quite some NVIDIA GPUs here in our systems. So there's a reason to have a closer look at how that can be used in visualization software. And yeah, it's a pity that the H200 will lose the hardware accelerated OpenGL support, but at least there are quite some GPUs around which make it worth having a look at that. You know that currently in the EasyBuild software stack, when we talk about OpenGL, we talk about Mesa. And so I will just go quickly through some of the backgrounds of Mesa, and then we have a deeper look at the vendor neutral dispatch library, which is there for quite some time now, and which gives some more when it comes to OpenGL and the independent OpenGL, I'll say this. So I borrowed that image here from Mesa itself, or at least from the wiki page from there. So you could see it's not 3D computer games we are wanting to accelerate. Yeah, they are at least not here on the HPC systems, but we are kind of coming from the same kind of challenge that, of course, with OpenGL, hardware accelerate OpenGL, we can make use of the GPU functionality. And in this diagram here, it goes through Mesa 3D. So let's have a first look on Mesa. Quite some years ago, Mesa started 1993. It's an open source implementation of the graphics APIs and primarily OpenGL, but also comes with Vulkan. EGL is quite important for us here at the HPC, and also includes OpenCL and other acceleration APIs, primarily for accelerating video decoding or things. So in general, Mesa translates these specifications to vendor specific graphics hardware drivers, and here Intel and AMD is quite well supported. But when it comes to NVIDIA, the Novu driver has some kind of, say, drawbacks when it comes to performance. And therefore, it's worth having a look how to integrate that and how to combine, have a software stack which can make use of also of NVIDIA hardware accelerated OpenGL. So when we talk about OpenGL, then we often mean to access that through GLX or EGL. You can see that the primary difference is that for the classical GLX, we need an X server, and for EGL, we don't. So EGL is kind of the nicer way, at least in our setups here. And but both have to, of course, have to be working and set up for that. Why is Mesa's Novu not an option? I already said, when, of course, the expensive HPC systems, we should better use the most optimized driver. So it's a hard requirement to use the NV or install and use the NVIDIA GPU drivers. And it's a pity, but Novo and the drivers of NVIDIA cannot coexist on the system side by side. So one has to decide this or the other. And for that reasons, there's no Novo on the HPC systems, and it's not loaded. So eventually that means that cannot base on that. And the proprietary graphics driver from NVIDIA replace, in that sense, all of Mesa, providing their own implementation graphics API. So that means having known Novo there means that if you go through Mesa and use OpenGL, then you're back on software. So there are multiple implementations, and the LLVM pipe is the one which is nowadays the standard. Just one comment that LV-REST is not there anymore. If you try to use it, then it's always falls back to softpipe and LLVM pipe. There was quite a nice implementation, at least I thought it's quite a nice implementation for our use cases, which was OpenSVR, but that's dropped. And probably, but I don't know exactly, but probably I could assume that LLVM kind of catched up. I could not find any comparison of the performance, which is kind of there from recent years, but I would expect that LLVM pipe now looks kind of catch up with OpenSVR, which was more high focused on the advanced vector extensions and made use of that. So when it comes to software, OpenGL, then we are down to LLVM pipe, which is fine, but which is not the best performance you can get, especially if you have the hardware accelerated NVIDIA GPUs in your system. Feels a little bit bad not to use that. So it's that was, I mean, we are here not the first to realize that, so it has been realized quite a long time ago. In September 2012, it was, to my knowledge, first proposed by Andy Reiger of NVIDIA to come up with a new OpenGL ABI, and that supports both GLX and EGL in any combination with OpenGL and OpenGL ES. So it boils down to have the advantage that it allows multiple implementations to coexist on the file system, or even allows multiple vendor implementations to coexist within the same process. So we can have now Mesa and the drivers from NVIDIA at the same time on the system, and can switch between these on the fly. So that's a big advantage, and as you can see from the releases, it's not something bleeding edge. At least I would not call it anymore bleeding edge. I think it's in all Linux distributions standard, and it's continuously developed. And you can see we are now at libgl VND for vendor neutral dispatch library from September 2023, and it's it's part of freedesktop.org, and so it's kind of a reliable stuff. So how does it work? In the past, applications were accessing the libgl directly. So whatever libgl you provided, the application will go to access that libgl and will make use of the functions there, and so that was the reason why you could only have one on your system, because the one which was found was used, and therefore you were stuck if you want to multiple libgl or multiple vendors. Now with the new OpenGL API, I don't, probably I should not call it new after 13 years. At least with the other current standard of OpenGL, the application will access actually through libOpenGL, and libOpenGL exposed the OpenGL core and compatibly entry points, and it's on the left side. It's only the view of the of GLX, so not EGL and some extras, but to keep it a little bit more simple, one can see that the application actually can access through can access the same OpenGL functions through libOpenGL, libgl-es, and also if it's an old application, it still can go through libgl. So there's no kind of compatibly breaking that applications which are directly accessing libgl still supported. Yeah, when it comes to dispatching, we have to distinguish between GLX dispatching and EGL dispatching, and the GLX is a little bit more difficult, because now if we have multiple vendors, of course when you open a context, then the dispatch library has to decide, okay, which vendor do I take, which GLX library eventually do I take, and this is done through an extension in the X server. So the X server itself defines, or the X screen itself defines which vendor to take, and from that on, all the commands which are accessing all the OpenGL commands will eventually end up in the right OpenGL implementation. One can override that, so in the beginning that the dispatch library will not ask the X server itself, but will kind of get forced to one of to a certain vendor if one sets an environment variable. So there's the freedom to not be forced to go through the X server and do all these kind of configuration stuff, but go through an environment variable to set. EGL is, to some sense, it's less complicated. It's doing this same as Vulkan. So you have a JSON library which defines which where the library to be the vendor-specific EGL library is found, and that is set also through an environment variable in a certain order, so that the dispatch library will actually check, these are the number of vendors libraries I have, and we'll go from the beginning to the end and try to kind of succeed with one of them, and we'll take the first one it succeeds for the OpenGL as the OpenGL implementation. And sure, the advantage here of EGL is you have no X server, so that makes things a little bit less complicated, and for the use case in the HPC. As soon as the context is there, then the OpenGL commands can be directly forwarded to the vendor library, and will be executed. Will call the correct functions there. So that's kind of easy. As the context is there, and if you want to know, okay, which driver do I actually use, one way to do it is, for example, with GLX-info or with EGL-info, find out which eventually was taken by the dispatch, by the vendor-neutral dispatch library. Okay, so how does that look? Actually, it's not, I would say, not too complicated when it comes to EasyBuild. We use it since a few years. So we have this OpenGL module, which is a wrapper around a few modules, including, of course, libgl, or with a wrapper around a few components, which is, of course, the libgl vendor neutral dispatch library, Mesa, and some of the the OpenGL utility library, extension wrangler library, and also the Mesa demos, because that provides the EGL-info command, which is quite useful. So perhaps one drawback here is that that glue itself decides at runtime if it's compiled for GLX or EGL. That's a pity. So I don't know if, we have it in there, but I'm gonna have to think if that's then the right place, because it's not, you cannot support both. Yeah, when it comes to I've already said with the GLX dispatch depends on the setting of your X server, and EGL on these JSON files, kind of same as Vulkan is doing it. And so you have to configure that, and that's also part of that EasyBuild module that we have one JSON file for NVIDIA and one for Mesa, and then we define these environment variable EGL vendor library file names, and therefore it will try first, when it comes to EGL, first try to use NVIDIA, and when it succeeds, it will end up using NVIDIA implementation for OpenGL. But if it fails and is on a node where there's no NVIDIA, it will then use Mesa.
Just the content of the NVIDIA.json, does that change over time, or is that has that been stable for the actual content of that JSON file? Does it?
That content is actually quite simple, because it just points to the library path. And it will look there in the LD library path where that library is located. So it's nothing more than pointing to that vendor specific library. So that perhaps I already can come to one of the kind of issues at our side. We have installed the NVIDIA driver on system level. So there was an NVIDIA driver module in the past, but as it needs to be in sync with the driver you install, it was always an issue. So it's now on system level installed, and therefore just having these libegl nvidia.so.0 in that JSON file will always mean you find that library because it's on system level. One might need to rethink how to do that in a more general sense. I don't know how that is on other systems. If these kind of NVIDIA component or AMD, when it comes to Lumi, is also installed on system level, or it comes in with its own module. At least, yeah, that's one of the open questions. Yeah, when it comes goes to EGL, therefore, I think it's quite straightforward. When it comes to GLX, it's more kind of complicated when we think of at least as a module. So I already talked about one of the open questions. So let me go through that, and we can stop at one of the more complicated things, or at least the questions. So I would say libgl VND is this standard. And it has real reasons to be used also in our software environment. It gives these additional benefit that we can have multiple vendors installed there. And the open questions is who is kind of ensuring that the libraries which are in that JSON file are in the LD library part. Is it EasyBuild itself which has to come with a module and then put it in, or is it on system level? That's kind of something to think of. On our side, it's on system level, so it's kind of easy. And when it comes to GLX, I already said the X server itself or the X screen defines which vendor is taken. That might not be always the good choice when it comes to modules. There one can override that with these environment variable, but then the question is, if one wants to do it automatically, does it need some extra logic to see, okay, I'm on this and this node, I have this and these resources, I override now from Mesa to NVIDIA. Yeah, so that's also one open question, and the last one, I could not test it with other things than with NVIDIA. So the definition says when loading that vendor library does not succeed, then it will go to the next option that works for NVIDIA. So and there's no NVIDIA card and EGL tries to load or the dispatch library tries to load that vendor library, then it will get a failure, and then it will drop to the next one, to Mesa. I'd like to know if that's for AMD the same. If there any case of using AMD Catalyst, I don't know. Yeah, so I think the main point is quite it's quite useful. The question is that something which is more specific, too specific for the general EasyBuild software stack, or is that something to be stack itself? I'm done. You can ask questions.
Yeah, so maybe I have a question about the HP 200. You said that doesn't come with that doesn't have this acceleration, doesn't have the.
Has no OpenGL on hardware level.
Does that have a problem in this case then, or that library doesn't exist, so it doesn't matter?
Exist. There's no. Okay. There will be a software.
Yeah, so we'll just fall back
by default.
Just one of the nice developments over the past couple of years is that virtual GL, since a few years, can render OpenGL applications directly to EGL and then go to the GPU without actually needing an X server running. So we have no more need for special virtualization servers with a 3-day X server on the node. I just wonder if you thought about adding virtual GL in that bundle to have like a whole top to bottom ETL TL.
So currently, virtual GL is its own module. Yeah, I mean, one could add it there, sure. It's, I think, a more question of what's the philosophy of these getting bigger, putting more into one bundle. We don't have it at the moment in that bundle.
Okay.
So you have some open questions on the details, let's say, of how we could get this into EasyBuild upstream. Have you also thought about easy? So would it make sense to have that kind of setup there and have good documentation, how people can control what kind of backend is being used? I mean, this presentation is fantastic, but it's still going to be very technical for some people. So we want something that ideally works out of the box and does the proper thing, even if it has to go through a couple of options somehow, that it's transparent, but that people that really want to convince it to do one particular thing still have a handle of doing that. Like, one thing that's not clear to me is you have these JSON files which have almost no information in them. Why are they just not environment variables or something simpler than? Why do they have to be files? If it's 100 lines of JSON, yeah, sure, then you need a file. If it's just the name of a library and a version,
I could imagine that if you install it, then from the installation procedure you can write to disk, but you hardly can, as some vendor, to install something,
control
you can
the
hardly control the environment variables.
Yeah, okay.
So the JSON file makes it easier.
Yeah, but pushing this into easy, would that make sense? Or I think it would.
Yeah, no, I'm sure. I mean, I will learn more about easy tomorrow.
Yeah. Okay.
So I tell you tomorrow.
Yeah.
Yeah, I mean, I think that the difference in easy is we actually control the linker, right? So this problem of finding the library is one that we can solve ourselves. We don't have to think about the system at all, right? We are the ones who decide where things get resolved.
I think that's my question is going in the same direction. So would it be possible to generalize it and also include the AMD libraries in this? So that you would have a general OpenGL library, and depending on the system you're running on, it would pick the right thing?
Technically, yes. I don't know on AMD systems is one using the Mesa, which comes from Mesa, or is one going to a Catalyst? To my knowledge, AMD Catalyst is kind of dying out, but I don't have access, or I have not used that.
AMD also depends on the GPU you're using. The Instinct series is like the H200. They don't have rastering hardware, so everything has to be done in software there. Though I believe AMD does have a software rasterer that uses the units on the GPU to accelerate, so can do a bit more than just the pure CPU emulation. Catalyst, I believe, is more the driver for the RDNA series GPUs, which are the visualization GPUs, and as far as I know, that's not dead. But there's a very strict distinction between compute GPUs and rendering GPUs in the AMD ecosystem. And all the compute GPUs cannot do hardware accelerated rendering.
So I think one has to distinguish between NVIDIA with or hardware with OpenGL, and if it has no OpenGL, then it's out of this context. Software rendering, anyway.
Thanks a lot.